Всем привет! Мы сегодня на .next Moscow 2021 открываем второй день на четвертом треке, и нас ждет сегодня потрясающий доклад. Его будет рассказывать настоящая рок-звезда программирования. Ну, то есть rockstar developer Дилан Битти. Дилан просто реально Дилана знают все. У Дилана есть своя группа, которая поет классные песни. Он много-много раз выступал уже у нас на .next, и каждый доклад — это реально произведение искусства. Экспертом сегодня буду я, Екатерина Куксенок, senior-девелопер из EPAM, и я думаю, самое время перейти на английский. Hey, Dylan, how are you?
Доброе утро. How you doing?
Well, great. I know that you speak Russian a little bit.
Я
How?
не говорю по-русски, я говорю по-rockstar. So,
Okay.
yes, I don't speak very
Okay.
much Russian. I was learning when I was visiting Russia for .next a lot, which was a lot of fun, and then CodeFest as well. And then obviously pandemic, and the one thing that I've been really bad at doing is keeping up with Duolingo and Babbel and all my language lessons. Because it's tough when you do that and you're like, I don't know when I'm going to be able to travel again. So here we are, and we do it online instead, and this is fine. So how you doing, Kate?
Well, doing great. Being an expert on your talk, it's amazing experience, I can say.
Oh,
And
yeah.
yeah, just wanted to ask you, how many talks are you doing each year, especially in this 2021 pandemic, so on?
Well, I'm doing 2 talks today, and one tomorrow, and 3 next week. I think I'm. It's going to be up to about 100. I think I've done 60 or 70, and it's now. We reached a point now where some events are starting to happen again. So I've done a couple of things in person where I've done live talks with a real audience, which is it's great to be able to go back to that. But also, what I sort of realize is there are some things you can do with an online presentation like this one, which would be very difficult to do in if we were doing this offline, if we were all in a room together. So kind of one of the things I'm trying to do today with this talk is I want to do something that we couldn't do in a conference center. So all the folks out there who are watching, hey everybody, I'm going to be sending you links, and I'm going to be sending you code snippets, and if it all works, because it's all completely live this, if it all works, then you're going to be running code on your own machines with .NET that's going to be communicating with my examples, and we'll be able to see what everyone's doing. So please, participate in that. Be nice. Please don't send anything that is rude or is offensive. Otherwise, we'll close the ports and I'll just do the whole thing on my own. But I've done this with a couple of different talks and got some live, not just kind of live participation, but actually live interaction with the code as well as with the questions and stuff. So yeah, do that. I'll
Okay.
send you code. You run it. Send me stuff. See what happens.
Okay, so we are waiting for interactive talk today,
Oh yeah.
right? Oh, that's really cool. I like it really much. This interaction with the public. It really helps. It's more interesting as for me.
And so I think we have. So I just want to do a quick experiment now, because I think there is some latency on the stream. Like the people watching, they are, I think, 20 seconds behind or something. So if everyone out there, if you're in the chat or if you're in the Telegram thing, just drop in a little message. Just say hello. I'm going to count 3, 2, 1. Then you post hello, and we'll see how long it takes those messages to come through. And if we don't get any messages, then we'll just assume that you're all sit quietly on the sofa watching this on a big screen or something. So 3, 2, 1. Post hello, and let's see how long those messages and chat take to come through. It's interesting doing talks online like this. I was just looking, I have like 6 different screens on my PC here, and I'm thinking next week I need to do this with a laptop and luggage again. Okay, cool. Yes, we have hello. Hey, Evgeny. Hey, Andrea. Hey, Vladislav. Hey, Dmitry. Hey, Elizaveta. We saw you already today. Cool. And it looks like they got this clever system where Telegram is connected to the website, right? So if you do web chat, it shows up in Telegram. And if you do Telegram, it shows up in web chat. So cool, it works.
Yeah, that's great. So maybe we could start?
Okay, let's start. So stay on the line, Kate. I'm going to be doing a whole bunch of stuff with .NET. So if you have questions about any of it, or if anyone has questions, ask in the Telegram or the web chat. And we're going to do some stuff with code. So first of all, just a very quick introduction, this is me, Dylan Beattie. I run Versatile, which is an online training consultancy company. I do workshops and strategy and all kinds of things, mostly over Zoom up till now, but now we're starting to travel around and do things in person again. I'm a Microsoft MVP with the Developer Technologies Program. I run the .NET user group here in London, and some of you might have heard of a little project I did a few years ago that got a lot of attention on the internet. I invented a programming language in a bar as a joke called Rockstar, because you know the whole thing on LinkedIn where like Rockstar developers and everyone's like, oh, we're looking for a Rockstar programmer. And somebody said on Twitter, why don't we make a language called Rockstar so that everybody can be a Rockstar programmer? So you can check that out at codewithrockstar.com. Rockstar, all the programs look like heavy metal songs from the 1980s. So you type in your lyrics and you click rock, and if it works, you are a Rockstar developer, and congratulations. And if you do that next time we meet up in person, show me the code and I'll give you your certificate. So today, we're going to talk about .NET, and we are going to talk about distributed systems with .NET, because there is this whole bunch of patterns now that exists for building and integrating microservices and components and stuff in .NET. And, you know, it's a famous saying from Linus Torvalds, talk is cheap, show me the code. Most of the talk today is going to be code. We're going to be doing live coding. I'm going to be demoing stuff for you, and we're going to be running that, and I'm going to be sharing little snippets and bits of code with you via the chat. And if you want to, you can get in, you can run those, and we can actually get all of that stuff working. So what we're going to be doing is, this is the system that we are going to be designing and building today. We're going to take a website. So I've got this very simple, it's called Autobahn, and it's a website for selling secondhand cars. And what we are going to do, we want a way that people can add their own cars onto this platform that we've got here. Now, I'm going to switch over now to Visual Studio. Let me just drop a link in the chat here. If you want to follow on with the code, all of the code that we're going to be using in today's session is in this GitHub repo. There we go. Yeah, if you want to just have a look at the code, or if you want to download a copy and try running it yourself, there are some credentials in there for things like message queues and connection strings. Those are going to be changed after the talk. So yes, those are there on purpose to make it easy for people to kind of play along with it. Don't worry about it. I'll cycle those as soon as we're done here. So what we're going to do, let me have a quick look at the setup that we have running here. So if I switch over to my Visual Studio, and I'm just going to stop all that. Now you see in here, we've got a bunch of projects in this solution. We've got a website, we've got a pricing client, pricing server. All we're worried about for the first bit is this, the Autobahn website. So I'm going to right click that, and I'm going to debug. I'm going to start a new instance. That's going to start that web application running. This is all, it's .NET Core, .NET Core version 3.1. So Linux, Windows, Mac OS, this should run on any of them. Now, if this works, if you hit this URL that I'm going to drop into the Telegram chat right now, you should be able to send requests to that website, because I have a port open through my firewall here in my house. So you should be able to actually get in and see some stuff happening on there. Now, let me show you what this website actually does. There we go. We got a couple of requests coming in. Nice. So this is our website. And basically, what it is, it's a massive list of cars. These are all the different cars in our database. So these are the car makes. So we got, you know, Alfa Romeo, and we've got Cadillac, and we've got Cupra, whatever that is. And this is car models. And then we got this big list in here, which is, now you see there's some problems with the information design. This is not a terribly good experience. But what we're going to look at in the first part of the talk today is there is a REST API. And it is a REST API because it has Hypermedia on it. So I'm going to open up a tool here called Postman. And Postman, if you've not seen it before, Postman is an HTTP client for developers. Basically, it's kind of like a web browser, but it lets you have much more control over the requests and the responses and stuff that you're sending. So if we do an HTTP GET, let me show you what it looks like in a browser first. So if I go here, /API/vehicles, and that's just going to give us this massive chunk of JSON, right? And we can go through and we can see all this stuff we have in here. And now the interesting bit here is this chunk of code at the top, because it's a hypermedia resource. It has references in it to, if you come across the idea in REST of hypermedia as the engine of application state, that's what this thing does, is it's saying, all right, you are here, you're at index 0, there are 5,001 items in this collection, you're looking at 10 of them, and the places that you can go from here are, well, you can go to the end of the collection, you can go to the beginning of the collection, you can go to the next page in the collection. Now, you notice there's no back. We can't go backwards from here because we're already at the beginning. So going back from here, that would not be a valid transition. That's not valid state. And so it does not offer us the option. Now, this is very nice, but it's just JSON coming up in a browser. We can't really do anything with it. And if we go over into our Postman API client here, and let me whack up the UI size on that so it works on the stream. And if I paste that URL, we're going to send an HTTP GET to that same address. We send that. And there we go. We've got a bunch of that come through here. And Postman is nice because it allows you to do things like follow on links. So if I control click, let's have a look. So the first car we got here is AA07 AMM. It's a Nissan Note. So if I click on next, now that opens it in a browser. That's not really what we want. So there is a little tool built into this, which is open source. So you can take this apart later and see how it works. If we go to our actual website, so we just go to workshop.ursatal.com, there is a link here for REST API. And that's blowing up. That's saying 404 error. It's like, well, I know that there's an API here, and I'm going to go to API/vehicles here, and if I hit that, that works. And then from here, I can say, okay, AA07, so we're on the first page. If we go next, and we page forwards, all right, ABY761. If I go forwards again, next, and you see now we have previous, and if we go back again, previous, and if we go back again. So this is Hypermedia. This is a RESTful API with some Hypermedia controls. But as you saw there, when we just go to /API, we get a 404 not found. Not a terribly friendly system. So the first thing that we are going to do is we are going to add what is called a Discovery Endpoint. So just like the way if you go to a website, websites have a homepage that says, hey, well done, you're here. This is the stuff you can do. We want to add a Discovery Endpoint, which is like a homepage for our API. So I'm going to jump over here into my Visual Studio. Now I'm going to set up a couple of little bits here. One, we are going to stop that running. And then I'm going to open a Windows terminal over here. And let's whack that up and CD. So what I'm going to do is I'm going to use a .NET watch run, so it just keeps recycling the application every time I change anything. CD.next, CD.next 2021. Okay. This thing, by the way, this is PowerShell, and the little console bar here is a thing called Oh My Posh, which is, so this is the Git branch that I'm on. This is the working folder that I'm in. The little green thing here means that the last command I ran succeeded and was successful. If I type something that doesn't work, you see it goes red. It means the last thing I ran didn't work. I think that's very cool. So let me go into .NET here and go into Autobahn.website, and I'm going to do a .NET watch run. If you've not seen .NET watch run before, what it does anytime I change a file, it's going to recompile the solution and restart it again. So that's just going to keep running and keep listening. This is using a fake database, so all of the entities that we're looking at there, they're in the back end, they're baked into the code, so I don't have any Docker containers or databases or anything like that. So let's go over here. Let's go into our Autobahn website and have a look at the controller structure here. What I'm interested in is this thing in the API here. I've got, this is a vehicles controller, API controller, and you can take the time. We only have 1 hour today. And normally when I do this, it's a 2-day workshop. So we're going to do the interesting bits at high speed. If you do have any questions or you want to know about any of this, just stick a message in the event chat or the Telegram chat. We got that open and we can see what's going on with that. So let me just open that back up. It looks like something here has dropped out for a second. Yep, no, that's good. Looks like we're okay. And yep, okay, cool. So what we want to do, we want to add a home page to our API. So I'm going to drop in another controller here. And I'm going to say that the root for this is going to be a public class. I'm just going to call it the API controller. It's going to inherit from the controller base. And I'm going to decorate this with these two attributes. First of all, the root on this is just API. So this is what responds when we get requests for nothing. And then I'm going to add a method in here, which is a public action result get. So I'll just copy that. So public action result get. And when we get a get, we're going to return content. Hello, welcome to the API. Okay, a little bit of move to API controller. Thank you, Resharper. Much better developer because Resharper picks up my mistakes. And now that should have rebuilt automatically. Did that rebuild automatically? Let's have a look. So if I go over here and I save everything, and did that pick that up? Let's take a look and see what do we got. So there we go. Yeah, that looks pretty good. That shouldn't be running. Let's kill that. That's fine. So we're going to go and hit that endpoint again. So where did my web browser go? Browser's over here. So http workshop.https workshop.ursatal.com 5001 REST API. Boom, look at that. We've got hello, welcome to the API. This parser error here, it's because that's not JSON. That is just text plain coming back from that. And if we hit that with Postman, you'll see that we get text plain coming back from it. So let me hit that and send, and boom, and there we go. Hello, welcome to the API. And look at the headers, content type, text plain. It is UTF-8 text plain. We could say hello in Russian if we needed to. But we don't want to say that. We want to send back some JSON. So what I actually want to do here is we're going to create a new object. So var result equals new. Now, this is just a new anonymous object because in .NET, we can do that. We can create classes without having to declare the types of, give me a second. There we go. Sorry, my little light here was just flickering for a moment there. It's very distracting. We can declare anonymous types. So we can say new message equals welcome to the Autobahn API. And then I am just going to return JSON result. Actually, I can just return result, I think, because we got some default content negotiation happening. And it's going to return action result. And that should be JSON result. There we go. It'll rebuild automatically. And look at that. So you see the orange there? Yep, it failed, but then it picked it up when we saved it. It reloaded automatically. Let's hit that again. There's go on that. And there we go. We've got message, welcome to the Autobahn API. So now let's just include some links. And then we're going to move on to the next piece of system that we're going to look at today. So message equals that. Now we're using a hypermedia format here called HAL. The Hypermedia application language. And one of the things that HAL defines is how do you put links in a JSON document that's being returned from a web API? Well, you do it by putting in a thing called links. So we're going to say links is a new object. I wish it wouldn't do that. Links is a new, well, what's inside links? Well, first of all, we'll have a self link. This is what's the canonical URI for the thing we are currently looking at. And that is going to be a new object. And that new object looks like this. It just has an href, which is /API. And then we are going to put in another link here, which is vehicles equals a new thing like that. And then the href for that is going to be /API/vehicles. Save that. Boom. Already rebuilt, already restarted. So we hit refresh over here. Hit go on that. Yeah, we go. And we now have some hypermedia, and we can follow that endpoint, and we can get that. So that's REST. That's hypermedia. That's how you do discovery and hypermedia annotations on resource types. Now, there's one other thing that I know we can do here. I know that we can add new vehicles to this system by making a post to that API. Because if we go to workshop.ursatal.com 5001/API, now here's one that I prepared earlier. If we go to API vehicles, now if we post a little snippet of JSON, I'm going to drop this JSON into the Telegram chat in case any of you, now you probably need to modify it a little bit because you can't have two cars with the same registration plate. But that is the snippet of JSON that we are going to post to this endpoint. Now, if I go onto the web front end here, and I'll show you what we got, then we'll do some posts, and I'll show you what we have after that. So let's drop that to there. Let's go makes, end of this list, Volkswagen Beetle, 11 vehicles, none of them is .next1. So we're going to go over to Postman, we're going to do an HTTP post, boom, hit that and refresh that screen, and there it is. .next1 has been added to the system. Now, we know that exists because we've read the code. We built the system. We understand that. Somebody exploring our API, they'd have no idea. Like, they have no clue that that thing even exists. If they got a /API, they don't know that that's a facility that's available. So we're going to add one more thing to this. We're going to add a Hypermedia actions collection. So in here, underneath links, I'm going to say actions equals new. And then I'm going to give this thing a name. I'm going to call it create equals new. Now, just let me check the syntax on this. So the method for this is going to be post. The href is going to be /API/vehicles. The type is going to be application/JSON. And the name of this is going to be create a new vehicle. And now, if we go back over to our API Explorer, and I refresh that, and I refresh that again because it's taken a second to build. There we go. And look at this. The Explorer component here has picked up that there is a Hypermedia action. We can go into create there, and I can paste in that little snippet of JSON that is over here. So I'm going to paste that from Telegram into this. Get rid of that. We don't need that. And I'm going to make this one .next8. And this one is going to be silver, and it is going to be a 2021 Volkswagen Beetle. We're going to submit that, and there we go. And there it is. So we got a 200. Yep, model name. That all looks pretty good. And if we refresh that, there it is. Now, you notice .next1 disappeared? It's because every time we recycle the application, it flushes the database because it's all baked into memory. That is not a bug. That's a feature. It's designed to make it easy to get up and running. So let's go and have a look at our PowerPoint slide. So we've got this. We've got a way that third-party clients now can use a REST API to add and remove vehicles from our system. But what we would really like to do is be able to notify something else. When someone advertises a car for sale, we want to tell the world. And we want to tell the world by pushing a message onto a message queue, onto an exchange, so that other services out there can subscribe to that. Now, you'll notice none of our data so far, we don't have prices for any of these cars. So we are going to use machine learning to calculate how much your car is worth, and then we are going to list it for sale on the website. And the way that we are going to do that is we are going to use RabbitMQ to send a message to the Autobahn pricing client, and then the pricing client is going to use gRPC to send that message to a pricing server. Pricing server is going to calculate a price. It's going to send that back. The pricing client is going to push a message on a queue to a notifier, and then the notifier is going to use a thing called SignalR, and we are going to get live notifications appearing on that website. So if you're browsing the website and someone lists a new car for sale, you'll get a pop-up saying, hey, someone just listed a 1985 DeLorean DMC Model 10 in silver, and you're like, that's the Back to the Future car. I want that car. So, and we're going to build all of that, and we have got 37 minutes to do it. You ready? So, first thing is we want this piece here. We want a this chunk. We want to create a publisher, and we want to send messages out on a bus. So the way we are going to do that, I'm going to jump in over here. We got .NET Watch Run is still running in the background. I'm going to stop that for a minute because now we need to run multiple services to make anything happen. So we're going to need a message bus. Now, to do this, I am using a library called EasyNetQ. I'll just drop a link to that in the chat in case you want to look up on that later. EasyNetQ, I like very much. It's a .NET opinionated abstraction on top of RabbitMQ that makes it very, very easy to build message queuing and message passing systems with .NET. Some of you might have used things like the Azure Service Bus or Amazon Simple Queuing Service and Simple Notification Service. Those are very, very good, powerful systems for running big apps in production. EasyNetQ is a very nice abstraction for building, demonstration apps and starting to understand the patterns that we use to make this stuff happen. So what we're going to do is I'm going to go over into my API controller, my vehicles controller rather. So this is the vehicles controller. And in here, we have a method called post. This is post here. And what we want to do here is we want to notify the message bus that there is a new vehicle. Now, the way we got to do this, we need to create a piece of shared infrastructure. The messages are going to be classes, and those classes need to be visible to our server and to our publisher and to our subscribers. Everything that participates in message queuing, that is going to need to know about the same kind of message. And because we're doing this in 37 minutes, I have created this already. There is a thing called a new vehicle message that looks like this. So we got a registration, manufacturer. Now, something to bear in mind about these kinds of messages, ideally you want them to be flat. You don't want to be taking object graphs where you've got child and parent objects and collections. You want to be sending ints and strings and date times as messages because it makes the deserialization on the other end much more reliable and much more straightforward. So we need to create a new vehicle message, and then we need to send it. So how are we going to do that? Well, what we're going to do is take a look at our controller here. I'm going to add a method to this, which is going to be called publish new vehicle message. So I want to be able to publish new vehicle message, and I just want to pass in the vehicle. I don't want this controller method to have to worry about the semantics of message buses and stuff. That's going to happen somewhere else. That method does not exist. All right, let's implement it. Let's create method that. And then method implementation is going to look a little bit like, first of all, we are going to create one of those. So this is probably use AutoMapper for this, but I want you to see what's actually going on under the hood. So registration equals registration, manufacturer equals vehicle.manufacturer.name, build a new message, and then we need to publish it. And the way we publish it is we go bus.pub_sub.publish message. And then we're going, hang on, why is bus? Oh, we don't have a bus. Bus doesn't exist. We need a bus. So where do we get a bus from? This is ASP.NET Web API. We need to inject it. So up here, our vehicles controller, iBus is the interface type that EasyNetQ uses. So iBus bus, and then we want to capture that inside a read-only field. So that is our private read-only bus. Okay, yay, brilliant, perfect, it works. Let's run it and see what happens. So I'm going to jump in over here. I'm going to do a .NET watch run. There we go, that's up and running. And then if I go over into my Postman and I do that post again, and I'm going to get back a boom, 500 internal server error, invalid operation, unable to resolve service, because we've not told our web application about buses. We've told our controller, hey, use a bus, but we haven't told the application, this is a bus, this is how it works. So we're going to need to inject that. So in our startup method, which is here, startup is where ASP.NET Core configures all of its dependency injection and services and all these kinds of things. So what I need to do in here is I'm going to say at the bottom of this section, services.add. Now, there's a couple of different patterns we can use to do this. The recommendation with this particular library with EasyNetQ, create one bus at the start of your application and pass it around and use that same instance for everything. And in ASP.NET, that is called add singleton. It guarantees that you get a single instance of that dependency that's passed around to all of your components. So iBus, and then we need to give it what is the instance you want. Well, we'll give it the bus. What is the bus? We haven't created it yet. Var bus equals, and at this point, it is going to be called Rabbit Hutch because EasyNetQ uses RabbitMQ. So Rabbit Hutch is the thing that creates the bus. And then we need to give it a connection string, and it happens that I have one of those pre-baked from earlier, which is in here. Which I'm not going to write from memory, but it is in, there we go. It's in our configuration file. If we have a look in appsettings.json, there we go, connection string Autobahn RabbitMQ, that will do. So I just want to paste in here, configuration.getConnection string. There we go. Semicolon on the end of that line. Done. We should now have a working message queuing system. Let me save all the things. Wait for our application to kick in again. It's running. How do we know if it worked? Well, first of all, let's hit it, make sure we don't get an error message. Boom, hit that again. And there we go. It's created a new vehicle called .next1, and it's a Volkswagen Beetle. Okay, this is nice. That seems to be working. How do we know if anything happened? Well, there's two ways. One is we can use dashboards and monitoring and visualizations, what they call observability. The other thing is we can write some code. So let's start with the dashboard approach. I'm using, if you have a look at our app settings.json, that is a rmq.cloudamqp.com, because those are the people who I give the money and they host message buses for me. So let's go over onto cloudamqp.com and have a look at what we got going on here. And I'm going to log in here using my GitHub account. And there it is. And there is our message queue. And let's go into our RabbitMQ manager. And this will give us a bit of visibility. Oh, look at that. See that? Number of queued messages went from 2 messages to 4 messages, which means something happened. We've got messages going through here. That's the message rate for the last 10 minutes. So that little spike there, if I go and hit that API a bunch more times, boom, 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 we should get, any second now, we'll get a bunch more little spikes cropping up in there. We'll come back and look at that in a second, because there we go. You see that? Boom, that spike there. That's our 5 messages going through. Let's build a subscriber. Now, we're not going to build a subscriber from scratch. I'm going to show you what one of these. Actually, no, we'll build one from, how are we doing for time? Yeah, we'll use one that I prepared earlier. So I got this thing here. This is called the Autobahn Audit Log. And if you have a look at the program.cs method that is in here, what we've got is a to-do, implement message subscriber. What do we need to do? Well, we need to subscribe to messages that are coming from that bus. So the first thing that we are going to need to do is create a bus. So var bus equals rabbithutch.create bus. Now I'm going to do something a little bit different here. I'm going to remove this configuration system we've got in here, because we're not going to use configuration. I'm going to hard code the connection string so that afterwards I can send you this code and you can run it and you can connect to that message queue and get your own subscriptions. So if we go and have a look at that, there is our AMQP URL. I'm going to copy that. I'm going to jump back over here and I'm just going to paste that whole thing in there. Like I said, yes, that is a live password. No, there is nothing else running on this platform. And yes, I am going to change it as soon as the talk is finished. So, hey, Kate, how you doing?
Great. That's really interesting.
So we got rabbithutch create bus. That's going to give us a bus. And then we want bus.popsub.subscribe. And we want to, well, what do we want to subscribe to? Well, we need to give this 2 things. We need to give it a subscription ID. So I'm going to pass in that subscriber ID there. And we need to give it a handler. What is the action? What is the code that runs when we get one of, that should be new car message. When we get a new vehicle message, what do we want to do with it? And we're going to do that by creating a handler in here. So we're going to say message, and then when we get one of those, let's do a console.writeLine, and we'll console.write message.model code. Let me do a bit of string interpolation here. So message.model code, and then message.color, comma, message.yeah. So there we go. That's it. We've got a subscriber, we've got a handler, and the last thing we need is we need a console.readKey. And the reason we need that is otherwise it'll subscribe and then it'll quit. It'll just exit straight away. So let's go over. This is the Autobahn Audit Log. So I'm going to jump over and open a new terminal window here. So spin up one of those. cd.next 2021, cd.net. Having .NET and .next in the same repo, I may regret doing that. Let's go into the Autobanda Audit Log and do a .NET run. Okay, it's warning us about async, but you see this? We had a bunch of queued messages that were already on there. The reason those messages are getting queued is because earlier I ran this and then I killed it without letting it unsubscribe cleanly, and so that queue was never disposed properly. But if we go back over to our Postman method here, and let me stick that on one side of the screen and that on the other side of the screen. There we go. So when I send a post request from here, Postman does not like being in half of a screen. Isn't that handy? All right, hit send on that. What do we get? Boom, there we go. And if we change these details, so we're going to post, this is going to be .next 2021, and it's going to be blue, and it's going to be a, what else have we got in here? Ford Focus. And let's hit send on that. And there we go. We got a blue Ford Focus. So this subscriber is receiving notifications via that message queue. And when they come on the other end, it's just logging something on the screen to say, yep, that worked. Now, if any of you out there wants to actually run this code, what you need to do is .NET add package EasyNetQ and then .NET run. And if I copy that whole lot, you'll need the messages assembly to do that as well. All right, if anyone wants to, I'll drop this code in Telegram. You'll need to grab the messages assembly that is from the GitHub repository to be able to run a subscription to this. But you're very welcome to try that out and see if you get it working. Question from Taras: why you don't use message queue? I do use message queue. That's what this is. If you're referring to a specific kind of message queue or a specific product, tell me what it is, and I'll tell you why I don't use it. Right. Next step, what we're going to do now is we want to calculate prices for these things. So you've seen how subscribers work. What we're going to do now is we are going to open up a different component. I'm going to stop that running. There we go. That's exited that. And in the other tab there, we're going to stop that website running. Now I have another application in here that uses the same pattern. Now, the way that gRPC works, gRPC is absolutely brilliant, because what gRPC does, basically, if you've ever worked with WCF or you've worked with SOAP or Disco or any of the things that for doing remote procedure calls, things that allow you to say, I want to run some code on another computer, and I want to run it as if it was a local method. gRPC is built on top of a thing called, it stands for, I think it just stands for originally Google Remote Procedure Call, but now I think it's just gRPC Remote Procedure Call, like they took the Google out. And it uses a thing called protocol buffers, which is an open source way of serializing data onto APIs and things, which is very, very performant. It's a very lightweight, very fast structure that maps cleanly onto data types that exist in various languages. Now, the way that it works, let's just, I'm going to spin this up. I'm going to clear that screen there. We're going to do a very quick demo and show you the way protocol buffers actually works. What is the thing that it does? So let's make a directory in here called that and go into Protoc. Protocol buffers is based on defining something called a protocol file. So if I open Visual Studio Code in there, and a protocol file is effectively, it's a contract. Let's new file in there, and we're going to call this price.proto. Now, let me whack up the font size in that. Don't show that again. Don't show that again. There we go. So we need to write a protocol file, which is going to define what is the relationship between our pricing server and our pricing client. What is the conversation between these two services look like? And the way that that thing is going to work is we need to, let me just bring up the example, make sure I get this right. Syntax equals proto3. That's the version of the protocol buffers format that this file is written in. We tell it what package is it going to be in. Well, the package here is going to be called price. We define a service. Our service is called Pricer. What does Pricer do? Well, it has an RPC, remote procedure call, that is called getPrice. And getPrice takes a price request. And when it gets a price request, it returns what? It returns a price reply. What are these things? They don't exist yet. We are going to have to define them. So then down here, we'd say, okay, this is our service. It has an RPC. This is like writing an interface or a method header, or like a header file in C or an interface definition in C#. This just defines how the service behaves without giving you any implementation. Then we say, what is a price request? It's a message. And it consists of a string, which is the model code. Now, these numbers here are field indexes. Don't ever reuse the same field index if you change the format of your messages. You can add new ones, you can deprecate them, don't reuse them. If you're running a system in production for a bunch of years, don't ever use the same number for something different than what that number was used for last week. So we got a string color equals 3, and we've got a int 32. What year is the car manufactured? That is going to be number 4. You'll notice that, let's make that number 2 in there. And then we need a reply. So message, price reply. And what is a price reply going to look like in here? Taras, I see your question. We'll get to that at the end. So price reply is here, and a price reply on this is going to look like, well, we don't want to know the price. I'm going to say prices are integers. We're not going to do with fractions of dollars or fractions of euros here. And a string currency code, we need to know what price. If someone says the car costs 5,000 rubles, hryvnia, dollars, pounds, euros, what is that in? So that is going to be field number 2. So this defines our protocol file. Then, this is the fun part. I come over here, and I am going to use a tool called Protoc, which is the protocol compiler. And what the Protoc does, if you just run it with anything, now you see all of these things here, Protoc will take that protocol file and it will generate headers and base classes for just about any language that you can imagine. So I'm going to run Protoc price.proto, and then I'm going to say --C# out equals dot. And just while we're in here, I'm going to do --Ruby out equals dot, --Python out equals dot. What else? Let's do some Objective-C. Why not? Just so you can see what it does. Missing field number, line 16, line 16. There we go. That needs to be field number 1. There. Okay, boom, run that again. And look at that. It's generated a whole bunch of code for us. So the C# file, price.cs, okay, so auto-generated, don't mess with this. And look at how much code has been generated here. This is the C# endpoint for doing a protocol buffer implementation based on that protocol. But then if we have a look at the Python one, there we go. That's the same thing in Python. If we have a look at Ruby, that's the same thing in Ruby. It always bothers me that Ruby is so small. Either that's very clever or it's not clever at all. I have no idea how they did that. And if anyone wants to, this is what it looks like in Objective-C. So we got the header files we can link into stuff, and then we've got the implementation. So if you really want to, you can use Objective-C to build native iOS applications that use protocol buffers. So that's how protocol buffers works. To use it in .NET, we don't use Protoc and then import it directly. We add some tooling to our .NET project. So I have an example over here that already does that. If we have a look at the Autobahn pricing client, and we have a look at our CSproj file here, you see this line here? We got protobuf. So down here, we got package reference. We've got all the other different types of content you get in a .NET C# project. Here we've got, this is a protobuf item. We want you to include, now you see this thing here? It's a relative reference. It's pointing to a file that lives in another project because the client is pulling in the protocol file that is actually defined as part of the Autobahn pricing server. And we've said gRPC services equals client. So when we compile our solution, that is going to turn that proto file into a C# base class that we can use as a gRPC client for us. So if we have a look at what we got here, this is the Autobahn pricing client. The implementation for this is actually pretty simple. So we've got an iBus. You've already seen how to build one of those. Rabbit Hutch create bus. Yep, we've seen how to build one of those. And we're awaiting a pubsub.subscribe async. This is fine. But then also, we've said create a gRPC channel and then create a gRPC client using pricer.pricer client. And pricer client, that's generated for us. That's the thing that gets spit out by the protocol buffers compiler, pointed at that channel. What is the config Autobahn pricing server URL? Let's have a look in our solution explorer and app settings JSON. That is workshop.versatile.com port 5003. Okay, cool. Main web server's on 5001. Pricing server is on port 5003 because they're not running as the same application. They are separate services. I'll show you why I've done that in a moment. And then we've got a handler here. When we get a new vehicle message, what do you want to do? Well, we'll take that message. We're going to unpack it, and we're going to turn it into a price request. We are going to do some console output. We are going to await a gRPC client.getPriceAsync. So we're going to send that request to the gRPC pricing server via an async call. When we get a response from that, we are going to turn that into another kind of message, which is then going to get published on our queue. Await pubsub.publish async outgoing message. Why have we published another message? If we go back to our architecture diagram, which is here, so we've built that part. We've built that part. We are going to implement this piece. But then when we get the price back, that price is going to be published out onto the bus again. It's going to go over here, and it is going to end up in the notifier, which is what we're going to see in the last part of the talk today. So we got a subscriber, receives a message, it bounces it off the gRPC server, and it sends back a response. We'll just have a quick look at the code in that gRPC server itself. So the Autobahn pricing server, it's an ASP.NET Core web application, and if we look in the startup, configure services, we got one line in there, services.add gRPC. And then down here, we've got endpoints.map gRPC service onto a vehicle pricing service. So that is all the configuration that's required. That's everything we need to do to add gRPC capabilities to a ASP.NET web app. And if we have a look at the vehicle pricing service, this inherits from the base class, which was generated for us. And if we have a look, that pricer base says that we need to override getPrice. That's the only method. Why is it called getPrice? It's called getPrice because in our protocol file, we said that is the name of the service. So that's the method we need to override and implement. And we've just said in here, every vehicle costs 5,000 euros, because that'll be enough just to prove that this thing is working. So I'm going to jump in over here now, and we're going to say, all right, Solution Explorer. Now, to get this thing working, we need to run more than one application at the same time. So just nothing is running there. Nothing is running there. Okay, and if you have a look at our set startup projects in here, this should be set to start the audit log, start the notifier, start the pricing client, start the pricing server, and start the website. Okay, this is good. We are going to do that, and then we are going to run that. It is going to spawn a lot of happy little console windows, if it works. That looks pretty good. Things are building. Things are running. So what do we got here? We've got the website. We've got the pricing server. We've got the pricing client. We've got the notifier. We've got the audit log. We are running multiple things. There's the website fired up for us. Thank you for doing that. And so what we are looking for now is we are looking for pricing calculations, which is going to be in this window here. So let's, where did that window go? .NET. Ooh, hang on a second. I think I closed the wrong window. That might be bad. Yeah, we're going to restart that again. All of these things have got console.read key, which means if you press a key, the process exits, which in retrospect is not a good way of running demo applications. Okay, so we've got the pricing server, we've got the website, we've got that's running, we got that running. There we go. That is the pricing client. That's the window we care about. And so now if I go over into Postman and I hit send on that, what I should get coming through there, boom. So if you see, of course, Control+, which is supposed to make the window bigger, is sending the read key, and that's what's killing it. We have time to fix that. So I'm going to stop that and just go into the pricing client here, and I'm going to fix that code so that it does not wait for any key and then exit the solution. There is the pricing client. There is program.cs. That is all fine. And console.read line. So I have to press enter to make it exit. Right, boom, almost there. How are we doing? We got 12 minutes to get this thing up and running, calculating prices, and sending messages to SignalR. So yeah, I think we can do that. That shouldn't be too difficult. So get all that lot up and running. There we go. There's the website. And let's just grab our pricing client window, which is here. And so now I can, there we go, make that, wow. Things with fonts. Okay, that's a command window, not a terminal window. Never mind. We're going to hit send a request to that. Boom, there we go. And that is indeed publishing, calculating prices via gRPC, and then it is publishing a new vehicle price message via RabbitMQ. So we've got to this point. We've got to the point now where if I point to options, erase ink on slide. So we are sending a request here by HTTP. That is going across to the publisher. The publisher is sending it there. This thing is publishing it. Boom. We are bouncing off the pricing server. We are getting a response back. We are publishing that onto the bus. And then we don't know what happens there because we have not plugged in the notifier yet. So the last thing we're going to do is we are going to implement SignalR on our website so that the notifier subscribes to these messages, and then it sends a request to the website saying, hey, please tell everyone there's a new car. And then SignalR, which is a really cool abstraction layer on top of WebSockets, will pick up that, intercept that request, and it will pass that on and display it on everyone's screen. So let's have a look at the code for our notifier. I'm going to stop that thing running there. Now, the notifier here, that is pretty much already built. If we go in and have a look at the implementation here, so what do we got? So there's a couple of things in here. One, we are using Microsoft ASP.NET Core.SignalR.Client. That is a new namespace that we've pulled in, which is a NuGet package you can run. And we are creating, we've got a bus. You've seen that already. We've got a bus.subscribe. You've seen that already. That's going to subscribe to messages. And then we have this line here, to do, send JSON to hub. How do we send JSON to a hub? Well, we need to take the message we got. We need to format that as some kind of JSON message that we can use to bounce messages across onto SignalR that will make sense when they get to the other end, because the other end of this thing is a web application. So in order to do that, we are going to need to plug in a little bit of extra code here, which means I need to look at, there we go. So first thing we need is we need a hub connection. Now, this is a command line application. We're not using dependency injection here. We're just going to plug in a hub connection to the hub. And then in our startup method here, we need to instantiate and connect a hub. So the way that we do that is hub equals new connection, hub connection builder. That's the thing that we need to pass into it. With URL, we need to give it a URL. This is going to be https workshop.ursatal.com 5001 / we're going to pick a path for our SignalR hub. It's going to be there. It's going to be on /hub. And I think we just need .build on the end of that. Let me just check. Yeah, that's right. So that's going to build us a SignalR hub. And then we want hub.startAsync. And then we say we're connected. And then in this handler here, when we get one of those messages come across on the wire there, what we are going to need to do is we've already got JSON convert.serializeObject. So we're turning our message into some chunk of JSON. And this is just await hub.sendAsync. And what is it that we want to send? We need two things. We need the name of a method, string method name, and we need the object that we want to send. And the name of the method is going to be notify web users. Now, doesn't matter what that is, but we need to remember it because we need to use the exact same thing somewhere else in a moment. And the message that we are going to send in here, we need the sender ID, which is going to be the Autobahn.notifier. And what is the payload? What is the actual thing we're sending? It's going to be the JSON. Oh. So handle new vehicle price message is going to do hub.sendAsync, and it is going to send code across to that. And we're now sending messages. Now, the last thing we need to do, and we got 7 minutes to do this, it's going to be fine, is we are going to plug in the SignalR component on the website so that we display real-time notifications. So if I go back to our autobahn.website and have a look in our startup method, now, we just need to wire this in. It's designed, the NuGet package is designed to be really, really easy to wire up to your application. So we are going to come in here and we're going to say services.add SignalR, which is all we need to do to plug in the supporting infrastructure, the bits and pieces which are going to make that work and get that wired in. And then we are just going to need to tell it about a SignalR hub. Now, we don't have a hub yet. So first of all, down at the bottom of the code here, I'm going to plug in a line that says endpoints map hub. And I am going to say that is going to be the Autobahn hub is the name of the hub we're going to create. And that is going to be @/hub. That's the route that it's going to use. Autobahn hub does not exist. Okay, so Solution Explorer, pin that. Controllers, there we go. We got a hubs folder. The hubs folder is empty. Right click, add new class. New item. Class. And we are going to call this the Autobahn hub.cs. And what does the Autobahn hub look like? Let's grab a copy of that. I'm going to cheat here. I'm going to copy and paste this because we're running a tiny bit short on time. Now you see this method here, notify web users. That needs to be the same name as that. So when we do hub.sendAsync, that is the method that is going to get invoked on the other side of it. Let's notify web users. Now, the first argument to send async here, that is another magic string. That needs to match something which is going to be defined in some client-side JavaScript code. But what we've said is when somebody says notify web users, I want you to do clients.all.sendAsync, and I want to say, hey, this user sent this message, and the key for that message is this. So that's the method that you should use in your client-side JavaScript to handle that. So we've got our Autobahn hub wired in. Let me just build that solution, make sure that works. The last thing that we are going to need to use, that's going to need a using directive. Yes, import that, please. That's fine. Rebuild that. So now, when we get a message pushed across the queue, it's going to send it to the hub. The hub is going to, the notifier is going to send it to the hub. The hub's going to send it to the website. The website isn't going to do anything with it. The reason for that is there is no JavaScript yet to handle this application. So the last thing that we are going to do today is we are going to come over here and we are going to add a chunk of JavaScript to our web app. So we've got Autobahn website, www.root, JS, site.js. Look at that. It's empty. So what we need in here, we need a function display notification. And this is going to take user JSON. And so when the server, when our Autobahn hub says send async display notification user message, that is going to get passed to this. This is the method that is going to get called on the client side. And what we are going to do in there is we are going to little chunk of JavaScript code there. It's using jQuery. We're going to console.log what we got. And then we are going to find a div somewhere on that page, which we defined earlier. It's part of our layout. We are going to parse the JSON that came in on the message. And then we are going to display a new message. So that's the handler. And then we just need a little bit of plumbing in here. We need a function that will connect to SignalR, which looks like that. So the important bit here, con equals new SignalR.hub connection builder with URL and then connection.start. And then finally, we just need to put a handler in that says document.ready, connect to SignalR. So when it loads, it's going to run that connection. And we have about 1 minute and 30 seconds left, and this is going to work. I can feel it in my bones. This is absolutely going to work. Let's run it and see what happens. So we are going to fire that up. There we go. It's running all of the services. It is going to wake up the Autobahn website homepage here somewhere any second. There we go. So I got the web server is over there. I've got my Postman API over here. And when I hit send on that, that's going to send a request. And there it is. We have live web notifications. New vehicle, .next 2021, Ford Focus. And if I change this to a 2021, just to prove it's not a pre-canned demo, and I'm going to change the car registration to, let's say, we got a question about pipeline-oriented approaches. So let's change the question to pipeline. Color for that is going to be gray, and boom, send that. And there we go, new vehicle registration pipeline, and there it is. And with that, ooh, cool, fun. And there we've got the first demo, but it doesn't matter because everything already worked by that point. And we've got about 15 seconds left. So what I'm going to do is I'm going to go in here. I'm going to go into the pricing server. I am going to, actually, no, I'm not. If you have a look in the GitHub repo, there's actually a version of the pricing server in the project as well that's built in Python to prove that gRPC works between the two different platforms. But we are out of time. So what we have done is we have done a very, very rapid implementation here of building that. The whole thing working pretty much end to end. We have sent requests via REST to a publisher that sends them on a bus to a client that uses gRPC, publishes them again. We've got a SignalR notifier hub in here, and we get live notifications coming out on the other end on the website. And that, my friends, is the distributed systems in .NET deep dive. Spasiba, thank you.
Dylan, thank you so much.
Thanks, Kate.
Well,
So,
yeah, I believe it's a great time to go to discussion because I feel that it's a lot of questions to discuss. At least a couple of
absolutely.
them are right now in chat. So, well, guys, please join us in discussions. А, Давайте скажу по-русски тоже. Пойдемте в дискуссию, поговорим еще. Мне кажется, куча всего осталось, что обсудить. Дилан, спасибо огромное. Дилан, thanks a lot. It's amazing talk.
And discussions английский, пожалуйста.
We'll try.
По-русски не хорошо.
Don't worry, I'll translate.
All right. Cool.
Cool. So see you in
Right.
discussion.
See you in the discussion.